Hi guys, welcome back. Now today we'll be discussing the usage of the ultrasonic sensor and how to interface it with the Raspberry Pi. We have different forms of ultrasonic sensor. This is a type. HCSR04 is a type. You can see it on the screen. So what is an ultrasonic sensor? From the word ultrasonic, sonic, sound, ultra, high frequency. So this operates by high frequency. The frequency of operation is around 40 kilohertz. 40 kilohertz is above the hearing of woman, so man cannot hear a sound frequency at 40 kilohertz. But the hearing aid of man is between 20 and 2 kilohertz, if I'm not mistaken. But for animals, dogs and so on and so forth can hear at a high frequency more than that. Now, high frequency does not mean it's very loud. High frequency means the number of vibrations of the sound per second. The amplitude determines the loudness. I believe we mentioned that in some couple of classes ago. So the amplitude determines how large it will be, how loud it will be. But the number of the frequency have to do with number of vibrations. So when the vibration is too low, below 20 hertz, humans cannot hear that. Okay, but when it is between 2 to 20 kilohertz, humans can hear that. But above 20, it is now ultrasonic. It is ultra high, so we call it ultrasonic sensor. So that is also the principle of these ultrasound sensors as well. So for the ultrasonic sensor, there are so many applications of ultrasonic sensor. Our aim is to design a robotic system that have all the features of man. Of course, man have eyes to see. With the eyes of woman, we can calculate distance. We can calculate, we can not actually calculate the actual distance, but we can calculate the distance between us and the obstacle. Like, oh, there is an obstacle a little bit far away. Let me run a little bit, or let me be slow, or let me turn to the right or left. We can do that. But with this sensor, we want to use this sensor to be able to measure distance, so that the robots or anything that we want to consult, you can measure the distance between it and any surface. It can be a liquid surface, it can be a wall, it can be a cloth, it can be woman, it can be anything. Once it is a surface, it will measure the distance between it and the surface. And how does it do that? It uses the principle of sound wave. So it has two transducer. One is the trigger and the other is the echo. What does the trigger do? When you supply a small pulse to the trigger, it sends 8 pulses, 40 kilohertz sound wave. When it sends it out, when that sound hits an obstacle, the obstacle reflects the sound back to the echo pin. So the transmitter transmits the sound, while the echo transducer receives the sound back. So let's take a look at this diagram. So the red is for the transmitting wave, while this blue, yes, is for the receiving wave. So when the transmitter transmits, the blue is for the transmitting wave, the red is for the receiving wave. So when the transmitter transmits the wave at a very high frequency, that is 40 kilohertz, when it gets to an obstacle, it is reflected back to the receiver. So with this principle, we can calculate the distance. We can write a Python code to calculate the distance between this sensor and any obstacle. So if you are using this in a robotic system, that means our robot can move from one point to another without actually colliding with an obstacle. It can also measure the level of water, because water is a surface, and so on and so forth. So the question now is, can it tell, like we have eyes, we can measure distance, We can also tell who is in front of us. Can it tell? No, this can't tell. So that's where the camera comes in. So in some other tutorials later, we'll be interfacing the camera with the Raspberry Pi and using the camera for video and image sensors. So this sensor is a low-cost sensor. It's very affordable. And these are the electrical parameters. It operates at 5 volts. You can supply between 3.3 to 5 volts to it, but the operating voltage is 5 volts. Okay, and the effective measuring angle is 15 degrees. That is, wherever you want to measure anything, it must have a space that can accommodate 15 degrees. So you can also use this to detect, like I said, any form of obstacle, whether car, liquid, obstacle, anything. So this sensor has 4 pins. It has the VCC, the trigger, the echo, and ground. Like I told you, the VCC and ground is for the power. So you can power it through the 3.3 to 5 volts pin of your Raspberry Pi. The trigger, you need to supply a pulse to the trigger so that it can send out the 840 kilohertz pulse, while the echo pin receives when this echo transducer has received the echo signal back from the obstacle, then the echo pin will communicate with the Raspberry Pi to tell it that, oh, I have received the echo signal. Okay, so how does this work? Through the microcontroller, you will send a 10 microsecond pulse trigger to the trigger pin. When you send it to the trigger pin, this sensor, ultrasonic sensor, will send a sound wave at 40 kilohertz frequency. 8 of them will be transmitted. When it is transmitted, automatically the echo pin becomes high. Immediately the sound pin is transmitted, it becomes high. So the sound wave is gone. When the sound wave hits an obstacle, then it is reflected back. By the time the sound wave is reflected back and gets to this echo transducer, then automatically the echo pin goes low immediately. So the time of travel of the sound wave from this sensor to the obstacle will determine the time at which the duration of I of the echo pulse. So we will use this duration of I of the echo pulse to calculate the distance of travel of this the distance the sound wave travels from the sensor to the obstacle. So how do we calculate the distance? What principle do we use to calculate the distance? So we know that the sound is transmitted in an open space. So that means the speed is the velocity of sound in air, and we know that speed is distance divided by time. So mathematically, if you look at this, the sensor to the obstacle, the distance between the sensor and the obstacle, if it is x, that means the sound will travel in the distance of 2x from this sensor to the obstacle. What do I mean? The sound travels x distance from this point to this point, then back. When it hits, it travels back to the sensor. That means it covers a distance of 2x. If the distance from this sensor to the obstacle is x, that means total distance travel is what? Is 2x. I hope you guys understand that. So since this is 2x, that since speed is distance over time, that means distance is equal to 2x. So that implies that the speed, when you substitute 2x back to the distance, that means speed is equal to what? 2x over time. So that implies when you cross multiply, that means 2x is equal to speed times time. So x then should be equal to speed times time divided by 2. So this velocity of sound in air is approximately 340 meters per second, although it changes with temperature. It is not constant 340 meters per second. It depends on temperature. So I believe you must have been taught in physics that the velocity of sound in air depends on temperature. So that means if you want to build a perfect distance measuring system, you must have a temperature compensated calculation to your calculation. But in this case, we won't use temperature compensation. In the next video, we'll be explaining how to measure temperature. So once we understand how to measure temperature, then we can actually compensate this formula with temperature so that we can have a more accurate distance measurement. But for now, we know that the distance of the velocity of sound in air is approximately 340 meters per second. So we can say distance is the speed divided by 2 times t. So speed divided by 2 then should be 170 meters per second. In centimeter per second, then we can say it is 17,000 centimeters per second. So that implies that x, which is the distance between the sensor and the obstacle, is equal to 17,000 centimeters per second times time, or 170 meters per second times time, where time is what? Is the total time. So the time is the total time taken for the echo pin to be I. Okay, I hope this is well understood. So how do we now write the Python code? How do we write the Python code? So guys, let's connect the hardware. This is the hardware. Like I said, it has 4 pins: the VCC, the trigger, the echo, and the ground. So I told you that the VCC and the ground are the power volts. So we'll be connecting the VCC to 5 volts of the Arduino, to any pin of the 5 volts, the ground to ground. Okay, the trigger is output because we'll be supplying voltage from the Raspberry Pi to the sensor. So we are not worrying with that because the operating voltage of the Raspberry Pi is 5 volts, is 3.3 volts. I'm sorry, it's 3.3 volts and not 5 volts. So you cannot supply a 5 volts to the Raspberry Pi, it will get it damaged. But you can supply 3.3 volts from the Raspberry Pi to anything. Okay, you can also supply 5 volts from it to anything that can handle 5 volts. So since we are sending the pulse to the trigger, so we don't need to worry. Since this can operate between 3.3 to 5 volts, so it won't actually work with it. But the echo is supplying the voltage to the Raspberry Pi upon receiving the transmitted sound wave back through the echo transducer. Okay, through the echo transducer, you can see the transmitter and the receiver. Okay, but the echo will communicate at 5 volts, which will damage the Raspberry Pi. So to prevent that, we need 2 resistors between the echo and the Raspberry Pi. Okay, we need a divider. So these 2 resistors will serve as a voltage divider. They will divide the voltage from 5 volts to 3.3 volts. Okay, so I prepared the resistors that will serve as a voltage divider, that will divide the voltage between this guy, which is this guy, and this guy. Now the principle of the voltage divider, I will explain that in some videos later, but we will explain that when doing the project on night sensor. So our robots can be able to detect when it is night, or when it is day, or when it is darkness. So we'll be doing that when we are dealing with night sensors. So when we do that, you can come back to refer to this video to understand how actually these voltage dividers are working. So what do we do now? We connect the trigger to GPIO20, echo through the voltage divider to GPIO21. So now I've connected my connecting cables. Can you see that? 5 volts, the first pin here, the ground, pin 20, which is the green, 2021. Now can you see it now? The 4 pins, I'm using a breadboard for the connection, so I'll plug the sensor in to this pin. But before plugging it in, I've already arranged the cables, the positive, the VCC. Can you remember? It is VCC, trigger, echo and ground. So the VCC is the red wire. I like using colors for red for VCC, black for ground, green for trigger, then other colors for echo to avoid confusion. So the red cable is connected to the 5 volts. Okay, you can see the diagram to the 5 volts, and then the ground is the black wire that counts to the position of the ground. Trigger is the green wire, it goes to pin 20. The green wire, can you see it? Pin 20. Pin 21 is the echo, which is the orange wire. The orange cable comes, it shouldn't come to the echo. I hope you know that. It should come to the point of the voltage divider between the two resistors. So this is resistor 1, resistor 2. Like I said, I will teach you what a voltage divider is and what is happening here. So between the two resistors, so from the first resistor, it comes to the echo. Okay, so at this point, so we have this portion that is going to ground. So you can have the ground connection. Okay, so that is the ground connection. Now you can plug in your sensor, okay, in that position. Okay, so with this we have our full connection. So we can plug in our Raspberry Pi to our computer system and write the code. So after you've powered your Raspberry Pi, then you can wait till it's connected to your hotspot. If you don't know how to connect your Raspberry Pi to your system, then you can watch the previous video to understand that. So then you will go and then open your VNC viewer. Okay, then check your IP, then double click on this, and that takes you to your Raspberry Pi desktop environment. So at your desktop environment, then click on, you can write your Python script in different ways. You can use your terminal. Okay, you can use the terminal to write your Python script, but it's somehow slow. It will be slow and it might take your time. So to make it faster, you come to your Raspberry Pi menu, you click on it. You can use this preference, accessories rather. At accessories, then click on text editor. When you click on text editor, then you type in your code. But if you type in your code through text editor, you still have to run your program through the terminal. Okay, which might be slower. But to make your work faster, you can just click on that icon, then click on programming, then turn it. Then wait for a few seconds, then it is opened. So you see a blank document. So how do we write our code? What do we do to write our code? So let's go back to the planning. Can you remember this formula? We've gotten that whenever you want to calculate distance, you divide the speed of sound divided by 2, speed of sound in air divided by 2, then multiply by what? By the time at which the echo goes from high to low. So as we've been taught in some chapters ago, in some classes ago, you must plan your code first. You must plan how you want to write your code. You must plan how you want to develop your software before you start writing your code. So my step is one, I want to set all my variables and functions. Then I want to set the trigger pin to be low first, just to like a reset. Then set it high for 10 microseconds. Can you still remember? So setting it high for 10 microseconds. Then after it is high for 10 microseconds, can you see it was low initially? My controller is sending a low, then setting it high for 10 microseconds and setting it low back. Can you see? So I have it that way. Okay. Set it low, low, setting it high for 10 microseconds. Okay. Then high, then setting it low again, then low. When you set it low, the echo pin becomes high. The echo pin will only come back low when the echo signal is returned. When the sound wave have hit an obstacle and the signal is returned, then the echo pin becomes low. So in as much as the echo pin is high, so the next thing is I will write my code to monitor the echo pin to check when it will be low. So I need to use the while loop so that it will be in that loop as much that the pin is high, it will stay in that loop. It will only leave that loop when the echo pin is low. I hope you understand. So I will just say while echo pin is low. So the loop will not be executed because the echo pin was high. It will only execute that pin when the echo pin is low. So as soon as while that is happening, then I will now start the counter. For start to I will at this point, then I will start the counter because it was high. Now I told you that the echo pin will be high for the duration of what? Of travel of the sound wave. So the echo pin is already high. I am waiting for it to be low. So I've started the counter. It will start counting the time. It will start counting the time. It will start counting the time until it is low. Okay. When it is low, then what happens? Also when it is low, it starts the counter. Okay. So when it is high, it stops the counter. So when it is high, it means this is back. Then when it is high, it stops the counter because I'm trying to program it that when it is low, while it is low, that means it was still high. While it is high, that means it has completed the what? It has completed the duration. Then from there, I can calculate the distance. So with that program step and explanation, then let me use that to write the code. Now I understand what I want to write, then I can develop the code the same way you've been taught in class. Okay, so let's now develop the code. Now I have typed in the code. The first thing, like I said in the plan, was to set all variables and functions. So this function will have add some comments. Like I told you, you always comment your code so that you can understand your code. Others can understand your code. Then when you come back to your code after you've left it for so many times, then you can understand what you've written while you were away. Okay, so this code will import the GPIO module, the input output module. Then this, you import the time library. This trigger and echo are two variables, and we've assigned the value to these two variables. So the trig variable will represent the trigger pin, while the echo variable will represent the echo pin. Okay, connected to pin 20 and pin 21. So this is just choosing the board, that is the board that has GPIO. Then at this point, then I'm setting this function will set the trigger pin as output. This function will set the echo pin as input. Then this is not necessary, just printing an echo message, a welcome message, just a message. Then why true? Why true? Can you remember? This will be executed whenever this condition is true. And this condition will always, because we wrote it as true. That means this loop will be executed forever. So that was why I said loop forever, because it will never be false because we type in true. Do you understand? So at this point, we are outputting a 0 to the trig. We are outputting a 0 to the trig. Can you remember? Supply a low to the trigger pin. Okay. Then the next, we wait for 2 seconds. Then we are now going to now make it high to output the pulse. Okay, the 10 microseconds. So we are outputting the 1, making it high for 10 microseconds. Then after, they will make it low. Okay. Then the next thing, after making it low, we listen to the echo to find when the echo will be low, because echo will be high immediately you send out the pulse to the trigger. The echo will be high. So this code will not be executed until the echo becomes low. So do you understand that? So once it is low, we start the time. Once it is high again, we stop the time. So when the time is stopped, then we can calculate what? The pulse duration. It's just a variable. Don't forget, it is equal to pulse end minus pulse start. Then the distance is pulse duration multiplied by 17,000. Can you still remember? Pulse duration, distance is pulse duration, which is velocity of sound in air divided by 2, is 17,000. The T is the pulse duration. Okay, so after that has been done, then we can, because it is a double, that is a floating number, a decimal number, it will have so many decimal points, so we can round it up to 2 decimal places. So this is the function to do that. And when you're done, then we can print out a message. The measured distance is, then time does sleep. So after this is done, then we can then run our program. Okay, how do you run? So you scroll up down here, then you click on run. When you click on run, you go down. Can you see? Welcome, Ismail. The distance is this. So now can you see the wall? The wall is actually about 200 centimeters from it. Okay, the wall is about 200 centimeters from the sensor. And you see the setup and the Raspberry Pi. Then, can you see that? Then what do you notice? You notice some kind of fluctuation, like kind of little fluctuation between the previous value and the new value. Like I mentioned, it is as a result of the temperature of the sound wave. The temperature is not constant, the temperature varies. And as you have been taught in physics, temperature affects the speed of sound in air. So you should expect this to happen. So when I bring this on this, then we add a kind of temperature compensation so that the distance can be more accurate. And so the distance is now 9.3 centimeters. Between the previous value and the new value is not that different. Okay.